Hello students, and welcome to the final video of this lesson. In this video, we're going to be using integration to solve particle motion problems. This time we're going to be given information in a table. So let's get started. So we're given a table here, and we're going to be using this table to answer different questions. In the first question, we want to know, okay, what does the value of 0 to 18 via t dt represent? Well, it actually represents a couple things. So the first thing is, since there's no absolute value here, you do want to immediately say, okay, this is going to be the displacement of the particle from t equals 0 to t equals 18. But one thing that you want to notice is that v of t is all positive. So you could also say that this represents the total distance of the particle from 0 to 18, because we know that v of t is greater than 0 from 0 to 18. All right, looking at our next question, we want to say, okay, using a left Riemann sum of 6 intervals of equal length, we want to estimate the value of the integral from 0 to 18. We also want to make sure that we do include units of measure. So one thing that I notice immediately is that, okay, all of these intervals are going by 3. So I can factor that out when I do my work. And that also gets me 1, 2, 3, 4, 5, 6 intervals. So I don't have to do really anything where I change anything up. It's just gonna be a really straightforward Riemann sum. So let's go ahead and write that out. So when I add all those up, I get about 33, and my unit of measure is going to be in meters. So now I want to do the exact same thing in this next question, but I want to use a right Riemann sum. So when I add all those up and I multiply that by 3, I'm going to get about 32.4 meters. Now in our next question, we want to use a midpoint Riemann sum. So let's go ahead and write out those values. And we do want to do this to 3 subintervals. So it's going to be a little bit less to write. So when I add those up and I multiply it by 6, because we're going by 3 subintervals, I'm going to get about 34.2 meters. Now here in part E, we want to use a trapezoidal sum. So let's go ahead and write that out. And when I add all those up, we multiply it by 3 and divide it by 2, I get about 32.7 meters. And now moving on to our final question. We want to find the average acceleration. So keep in mind, we're given velocity, so I want to go down. You're thinking derivatives, things like slope. And we're going from 3 to 9. And for what value of t in the table is this average acceleration approximately equal to v prime of t? So first, let's find this average acceleration. So I'm going to say average acceleration. It's going to be approximately, so we want v of 9 minus v of 3 over 9 minus 3. So v of 9 is 1.3 minus v of 3, which is about 2.7 over 9 minus 3. And this one I'm going to just plug into my calculator. I get negative 0.233. And since this is acceleration, this is meters per second squared. So one thing that we're going to have to assume here is that this table gives us the values of a twice differentiable function. That's going to be very important, because what we're going to bring in here is the mean value theorem. And in order for the mean value theorem to work, we need to know that the function can be differentiable at every value in between 3 and 9, and that it's continuous everywhere from 3 to 9. And we're just going to make that assumption here so that we can say that the mean value theorem guarantees a value between t equals 3 and t equals 9, such that v prime of t, such that like v prime, the derivative at one of these values between 3 and 9 is equal to the average acceleration. So from our table, since we're finding the average acceleration from 3 to 9, we can't really pull too much from the table, but we can say that v prime of 6, because that happens between 3 and 9 right there in the middle, we can say that v prime of 6 is going to be roughly approximately equal to the average acceleration. And that is going to conclude this lesson, this series of videos. So you do have some quizzes coming up, you do have more lessons coming up, so stay with it, keep working through these problems. I know it's towards the end of the year, review is happening and everything's happening in your lives, but make sure you stay focused on calculus and you keep working through it. Of course, if you need any help on these problems, you can always reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.